For example, during the Apollo program, a large set of experimental equipment was actually left on the moon, on the surface of the moon. And the moon is also a cold environment when it's certainly when it's not sunlit. So RTGs were actually used to first simply to keep the experimental packages warm, and then later also to both keep them warm and also to generate electricity. And typically on the later packages they generated 70 watts of electric energy. And these experiments gave us actually a lot of new know-how about the moon in the early days of the moon exploration, which probably would not have been possible without an energy source like this. A more modern example is the Huygens-Cassini mission going to the planet Saturn and actually deploying a lander that went down and landed on the moon Titan. This happened in January 2005 and was really a record-breaking event in the space history. Landing on another planet's moon was a great thing, and this was to keep this warm on Saturn. It was more than 100 small RHUs just to keep the warm, and some RTGs to also generate power. And an even more recent example is the US mission New Horizons, launched in 2006. That went all the way out to Pluto and actually sent back some fantastic images of Pluto in 2015. And this was powered by a general purpose heat source RTG, so to provide both thermal control or heat and also electric power. And here I assembled some more technical details on it. It's a package weighing roughly 60 kilograms and can generate 300 watts of electrical power, 4 kilowatts of thermal power, and the source itself was 7.8 kilograms of plutonium. And the last example is the Mars rover, the last one. There has been several, as you might know, but this one, Curiosity, is the latest and the biggest one. It's big as a car and is powered by an RTG, and this is also providing us a lot of good data from Mars, and is regarded as needed to explore the possibility for potential to do settlements on Mars in some distant future. There is also some further evolution of the RTGs using the Stirling principle, and not go in detail of this because I don't know them myself, to be honest, but with this Stirling principle you can gain 4 times more energy out of the same amount of plutonium. And here you see typically some data with only 1.2 kilograms of plutonium and a total system mass of 30 kilograms. You can generate 130 watt, and this has also a long lifetime, plus 14 years. This is actually being developed both in the US and has also been developed in Europe, planned for various missions within the ESA system. But even these more effective systems doesn't take away the fact that we have to send nuclear material into space, and there is typically a will, and we will try to avoid that. So there is also an initiative in ESA going on right now. Actually, this picture is from ESA conference in September this year, where they are seeking technologies to replace this RTG technology. And one of the things is fuel cells that seems to be attractive. So regenerative fuel cells is a topic that is being investigated right now for these kind of typical lunar and Mars exploration missions. And yeah, I mentioned this because hopefully we will be involved in this here also, but we'll see about this. Fuel cells, however, has actually been used already on the space shuttle. The space shuttle has a power system consisting of 3 separate fuel cells, and they provide all the power needed for the space shuttle from the cord is pulled on the launch pad until it has landed again. And even the water produced as a byproduct is used on board the space shuttle from the fuel cells, and the excessive heat is also used. And these 3 fuel cells together can generate 7 kilowatts of continuous power, or up to 12 kilowatt peak power. A package of, this is the package of one fuel cell, weighs roughly 50 kilograms, and it generates this power on a 28 volt DC bus, which is typically what you have on the satellite also.
Does it include the gas?
Yes. This has been mostly a success, but actually there was one mission in 1997 where shortly after launch one of the fuel cells started to give faulty readings or sending signals that something might be wrong, and this could not be sorted out in space, and they actually shortened the mission from 16 days planned to only 3 days due to this problem. So fuel cells might be potentially good, but it's also perhaps more complicated, at least than harvesting from the sun. Finally, I tried to see what more is going on, more exotic ways of generating energy, and a lot of studies has been done, and I found this report and I started reading it, and I was thinking about this movie Martian. Have you seen that? It's the idea is to create energy from either human waste material or other biomaterial. But I didn't have to read on into this report to find the conclusion that the net energy produced was roughly zero. So altogether, my thinking was, why are we doing this? We still have the sun there. It's easy to harvest. So don't jump over the river to find the water, right? The sun is still one of the best, most accessible, safest and easiest way to harvest energy when you're in space. So solar panels with better batteries, and that's what we are expecting from this project. That is still a very good way of generating power.